Morris, Kip Thorne, and Uri Yurtsever explained in some detail how such wormholes could be engineered. Responding to a question from Carl Sagan, they described the energy requirements to keep wormholes of varying sizes open. They also pointed out that based on quantum fluctuation, so-called empty space is continually generating tiny wormholes the size of subatomic particles. By adding energy and following other requirements of both quantum physics and general relativity, two fields that have been notoriously difficult to unify, these wormholes could be expanded to allow objects larger than subatomic particles to travel through them. Sending humans through them would not be impossible, but extremely difficult. However, as I pointed out, we really only need to send nanobots plus information, which could pass through wormholes measured in microns rather than meters. Thorne and his PhD students, Morris and Yurtsever, also described a method consistent with general relativity and quantum mechanics that could establish wormholes between the Earth and faraway locations. Their proposed technique involves expanding a spontaneously generated subatomic size wormhole to a larger size by adding energy, then stabilizing it using superconducting spheres in the two connected wormhole mouths. After the wormhole is expanded and stabilized, one of its mouths, or entrances, is transported to another location, while keeping its connection to the other entrance, which remains on Earth. Thorne offered the example of moving the remote entrance via a small rocket ship to the star Vega, which is 25 light years away. By traveling at very close to the speed of light, the journey, as measured by clocks on the ship, would be relatively brief. For example, if the ship traveled at 99.995% of the speed of light, the clocks on the ship would move ahead by only 3 months. Although the time for the voyage, as measured on Earth, would be around 25 years, the stretched wormhole would maintain the direct link between the locations, as well as the points in time of the two locations. Thus, even as experienced on Earth, it would take only 3 months to establish the link between Earth and Vega, because the two ends of the wormhole would maintain their time relationship. Suitable engineering improvements would allow such links to be established anywhere in the universe. By traveling arbitrarily close to the speed of light, the time required to establish a link for both communications and transportation to other locations in the universe, even those millions of billions of light years away, could be relatively brief. Matt Visser of Washington University in St. Louis has suggested refinements to the Morris-Thorne-Yurtsever concept that provide a more stable environment, which might even allow humans to travel through wormholes. In my view, however, this is unnecessary. By the time engineering projects of this scale might be feasible, human intelligence will long since have been dominated by its non-biological component. Sending molecular-scale self-replicating devices along with software will be sufficient and much easier. Anders Sandberg estimates that a 1 nanometer wormhole could transmit a formidable 10 to the 69th power bits per second. Physicist David Hochberg and Vanderbilt University's Thomas Kephart point out that shortly after the Big Bang,
Okay.